Yeah, so this is about clean coding practices in Golang. My name is Willem van Ketwich. I'm a senior consultant at ThoughtWorks. I've been in the IT industry for about 15 years, mostly as a software engineer. I'm passionate about a whole bunch of things in IT, but mainly software engineering, data security, and digital rights. So this would fall squarely under the software engineering part. Polyglot programmer, worked across a whole bunch of different types of code bases. About 8 years in C#, and a whole bunch, and yeah, like everything there. But only 1 year's experience with Golang. So please go easy on me with this. And if there are any errata, I'm more than happy for you to let me know. Cool. So the format for this talk, I thought I pointed out at the beginning. Most talks are just like someone getting up and talking. If possible, I understand some people may be making dinner or can't get to their microphones, but if you have an opinion about something, feel free to interrupt me and ask any questions or make comments as you feel necessary. I will not be offended. Yeah, and a lot of what I say is opinionated. It's my opinions on things and how I see things work on projects and with code bases. And feel more than free to counter my opinion. That's what healthy debate's all about. So the goal of this talk isn't necessarily to impart my knowledge, although a lot of it will be about my knowledge, but it's more to spark conversation. There's a saying in IT, or at least amongst developers, that we hold strong opinions and they are held loosely. So we're very passionate about the opinions that we have, but we're also open to other people's points of view. And this talk is not so much about the code. In fact, as a disclaimer, there are no code snippets in this presentation, but it's more about the approach to coding and the theories and the ideas behind it. And hopefully that'll capture the attention of some people. Yeah, and as I said before, your participation is both welcomed and encouraged, or at least I'll leave it to that. Cool. So what is clean code? Well, my first introduction to clean code was probably about, I don't know, 6 or 7, maybe 8 years ago, with a book by a person called Robert Martin, affectionately known as Uncle Bob, who wrote Clean Code. He's also gone on to write other books. I actually have it here, Clean Architecture. I don't know if we can see that, sort of, anyway. And a whole bunch of other books around that. He's got the Clean Coder and the software journeyman or craftsman, something, I don't know. Yeah, so he is, I guess, known as the expert in clean code. Although some of his other opinions are not as readily accepted or even frowned upon, he does have good knowledge in clean coding. So the term clean code is often seen as like a nebulous term that applies to, or is at least synonymous with high quality code a lot of the time. And so I'll try and attempt to unwrap that a little bit, just with some of the ideas that I have around that. Clean code is, in my opinion, it's code it's easy to read. Code that you can look at for a first time and make sense of it. You may not be able to understand completely what it's doing, but at least it's not jarring on the eye when you look at it, and you can grasp some insight from the code. And obviously there's different, there's a spectrum of that as well, right? Like, I mean, like you can go plate things to the point where it's just beautiful, but it'll take you like years to get to that point. But there's an in between that is pragmatic for most people. And clean code is in my opinion also easy to understand and maintain, and that maintainability is very important. And it's also sort of on that continuum. It's a journey and not a destination. So you might aspire to have fully clean code, and you might have all the theories in your head around how to do it, but time might be against you on that, and so you can just do what you can do. Cool. So why would we want to do clean code? There's a whole bunch of they're called ilities, and I think there's a book called Evolutionary Architecture that goes into a lot of this. But essentially, things like maintainability, and where you can look at a piece of code and you can change that in a way that makes sense to you and it makes sense to other people. Extensibility, so you can add on your code base in a way that is easy to do. That's sort of like changeability as well. Readability I talked about before. Testability. I'll talk a little bit about that later, but code that is clean, if you're writing a test afterwards, it's a lot easier to write those tests. Ideally, you do your tests first, but if you are going the other way, then adding those tests retrospectively is a lot easier if the code is easy to understand. And there's a whole bunch of other reasons. One of the main ones I always say to people is that if you've written like a whole bunch of code, there's only so much space in your head to remember everything, right? And if you come back to a code base, maybe 6 to 12 months later, even like a couple of years later, there's no way you're gonna remember everything, especially if it's thousands and thousands of lines of code. So having good clean code practices in place to begin with is essential for that maintainability and extensibility, which I just mentioned before. Cool. So yeah, as I mentioned before, I work for ThoughtWorks. It's an awesome company. I don't think we're hiring at the moment, but when we are, look us up. Yeah, so ThoughtWorks has our head of engineering is a person called Evan Botcher, and he put together some guiding principles back in 2017. And at the core of those principles and values are 4 key components. And so the 4 are a clean code, and then they sort of fold over each other, right? Like they sort of complement each other, those 4, and they sort of fan out to other sort of principles. And then, yeah, so they're clean code, simplicity, repeatability, and fast feedback. And so, yeah, so having one is not a guarantee that you will have all the others, but it goes a long way to getting all those. So fast feedback is essentially around like having unit tests and test cases, integration tests, all that sort of thing. So you as a developer can tell if you've broken something, and that comes back to changeability and maintainability as well. Simplicity and clean code, they sort of go hand in hand. Clean code, I guess, is more like the explicit definition of simplicity. But simplicity, I guess, more defined is across like not just the code, but the way the code base is structured and how that fits in with other projects as well. Repeatability, cool. So repeatability is mainly around, and that comes back to tests as well. If you have flaky tests and they fail sometimes, they pass other times, that's not great. So having the ability to repeat those tests in a way that you are confident about improves your confidence around the system you're working on. And a lot of it comes back to confidence as well. Cool. So the areas of consideration with clean code that I'll touch on today: structures of your project. So test and the application. I've sort of split test and application out. I just wanted to make an explicit call out to tests because they are quite an important part of structuring your project. A lot of this, like, I understand that clean code it defines code, but it extends to the architecture as well. So I've sort of conflated the two into this talk. At what I would think is the core of clean code is the formatting and style of your code base. I guess some of it's with your structure of your project as well, but just having things laid out in a reasonable way is goes miles towards that understanding of the code base. And tools and utilities to help you in the journey. So there's a whole bunch of tools out there that can help. Anything from linters to testing frameworks and but I'll go into a little bit of that later. And then, so once I've talked about that, I'll go into how it's an ongoing process. Refactoring your code base and cleaning as you go. So not just leaving your code in a state of disrepair and rot, but having initiative and working on the code and fixing things around what you're working on as a good good practice. And finally, I'll talk about some issues and influencing for your clean code. And in these two final sort of areas, I guess, like they're not they're not fully fleshed out, but you know, if we can have some conversation on that, that'd be great. Cool. So the structure of your project. I'll start with tests. My advice is to always use TDD. It's sometimes difficult, especially if you're coming onto a project or a code base that hasn't been the norm. It can be difficult to get back into a test-driven development type sort of pattern with your work. My opinion, and I'm happy to be called out on this or have a conflicting opinions put to me on this, but I aim to have above 90% and ideally 100%. The reason being that if you make any change, so if you have the smallest request with something that needs to be changed, if you don't have that 100%, there is some possibility that the change you make could break something and you'll never know about it. And that comes back to confidence. So how confident are you in the code base and the ability to be able to make changes in that code base? But that's not really a structural thing. The only guidance I give around the structure of your project, just put your tests in a separate path to your main source. There's a thing called the testing pyramid. So at the bottom, there's unit tests, and they should be what you're striving to achieve to get the most of. So for every new piece of functionality in your code base, there should be a unit test. And on top of that, you'd have, like, depending on what you're working on, you know, it could be an API, it could be like a website, whatever it is, you'd have integrate or microservices, whatever it is, you'd have integration tests across that. And there's not as much need to have as many integration tests as there are unit tests usually, because those integration tests cover like a wider surface area of your code base. And they're testing usually a lot more things in a lot more detail. And at the top of the pyramid, there's the acceptance tests. And that could be things like user testing, UAT environments, that sort of thing. And yeah, and there's also things like performance tests, smoke tests, that sort of thing. They're sort of in the minority as well.
Hey, Will, so couple of questions.
Yeah.
How come you picked 90%? Like, is this an arbitrary thing of gut feel, or do you have statistics to back up that, okay, this is like a sweet spot?
I don't have statistics around that. I've just found in general that gives a, you know, like if you're doing TDD, you'll ideally have 100% most of the time anyway. But if you're going the other way, it's just it's a line in the sand. It's somewhere to say, look, you know, I feel personally that, you know, if we don't have at least this in our project, there's going to be problems when we try and change things later on. And a lot of projects I've worked on, there is, you know, there's been that sort of, it's just it's a number, right? Like, I mean, it's arbitrary, but it's something I've found that has been useful. Yeah, you could make it 95%, but, you know, is that too fine? Or, you know, 90%, it's usually enough, I guess.
I guess the main reason I ask is I feel like personally, from what I've experienced in the past, there's sometimes trade-offs between tests, right? So I guess the way I think about it is, if you're going to take me a week to solve a really complicated test case or something that I'm looking at is particularly complex, sometimes I'd rather just put an integration test or something that's just going to touch upon it and not have such fine-grained confidence on the small components that comprise that thing.
That's a good point.
Yeah, and then the percentage of the code coverage in a report becomes less important sometimes. But I guess I think that the second point I was going into is, I feel like with the more, I'm also an advocate of the testing pyramid, like you put, but I've been finding myself with the new technologies like containerization and the microservices kind of world, I've been finding easier and easier to add tests that like touch a lot of touch points, especially because we have so many touch points. And I guess you call them integration tests in a way. I've been finding myself more and more not having a pyramid and more like a a rectangle down the bottom.
Yeah, that's a good point. Like, yeah, even on the last project I was working on, that was a Golang project. And yeah, so I came onto that project late, and they hadn't been doing full TDD. And the test coverage was probably about 70% in the unit tests. But they had decent integration test coverage. And that was what was saving them. And it was a super complex domain. It was all about this retail stuff that was just mind-blowing. But having those integration tests were good, but they were still moving slowly, right? Because they didn't have full confidence in the code. And, you know, like they were making changes that were breaking in the build. And we actually had to stop for a sprint and, you know, increase our test coverage in the unit tests. And we started moving a bit quicker again. There were other things that slowed down that project, but yeah, I guess that's just you know, it's a case in point. It's just my example, but yeah, it's a way.
Just on those 90%, like, you know, do you think maybe whether it's 90% or a lower or a higher number, there's like a tipping point somewhere where, like, if you're below that, it's probably going to get worse and worse because no one will ever want to have that sprint where they clean things up. And like, say, once you hit 40%, and unless you intervene at that point, you might as well throw things away because it's not going to get better without massive intervention.
Yeah, that's a good question. Like if it's been at 40%, it seems like it's not even like a serious consideration by the devs on the team. At least in my opinion, it's like they've just given like lip service to whatever, you know, the like the testing framework and, you know, putting those tests together. But it's not really, yeah, I don't know, at 40%, and it would depend on how much the code had been written as well, and what those tests were around. You know, like if it was like maybe the parts that had the test could be just like, you know, they could be picked out, and then, you know, everything around it could be thrown away. Yeah, it just depends. I mean, yeah, Berger, you're a consultant, you know.
Oh no, of course. I'm just saying, like, but like, I think you kind of answered it because, like, yeah, 40% would definitely indicate other problems.
Yeah.
But then, like, does it have to be 90% or, you know?
Yeah, yeah.
Again, it's not a fixed number, but maybe there's
obviously there's probably a point where it's unsalvageable, and it would depend on like the domain that's being worked on, and what those tests cover as well, and as well, like back to Gustavo's point, you know, if there are other tests for integration tests, maybe that's a saving grace for it as well. So yeah, it just depends.
I guess also, in a way, the way I see the percentage is like, okay, this is an internal agreement that we have, and it's an easy way to communicate with non-technical parts of the business that, hey, the confidence that we have in changes grows and lowers based on some metric that we have. It's easier to say, okay, here's the metric, here's the report, here's how we've been progressing. We need time to adjust it or time to improve this metric somehow, and it becomes an easy conversation as well. And at that point,
that's exactly right.
I think it's also important to understand that the metric doesn't give you understanding of the quality of the test as well. I've worked on projects where I've had 90% test coverage, and, you know, the tests have been garbage. You know, they were just, you know, testing null and those things, not actually testing any actual, you know, business value. So it's, you know, it's
yeah, that's a good point too. Like, and that comes back to a core point around clean code. Like, clean code is there to, you know, like give the ability to extend your code. And if you can't even read the test or understand what they're doing, like, you know, what's the point of that? And if they're all testing a similar part of the code base and everything else is just not
I mean, because test the code as well, and you should have clean code tests.
Yeah, exactly. Yeah, absolutely. I've seen in the past, you know, the given, when, then approach to naming your tests in the method name. So that's how it's often how acceptance criteria are written, and that's quite useful as like a pattern to use for your tests, because it makes it clear exactly what that test is doing. You know, given given I have you know, like a shopping cart with 5 items in it, when you know, something is a promotion is applied to it, then I will get this discount. Things like that. Yeah. Any other comments, questions?
Well, it could also indicate that, let's say, if you did integration tests, like let's say you did just integration tests, like theoretically they should still cover most of your code. But if you find that they don't, then that could mean that there's way too much branching, that there's dead code that's completely unreachable, things that should probably be removed or sort of separated and refactored.
Yeah, absolutely. I didn't actually put this in the slides, but there are code coverage tools. One of them is SonarQube, which I found is quite useful for Golang. And SonarQube actually tells you line by line what is covered by your tests. And so if you've got all those dead code branches and you've got integration tests that are running, you can clearly see which ones aren't being covered by your integration tests. That can help to find those dead branches. Not always, because like if the tests have been removed, it's not going to work.
That's right. But I guess the thing is, like, in that scenario, the answer would not be to write more tests. It's actually to remove those dead branches.
Yeah, absolutely. Yeah, there are. I'm not sure if there are with Golang, but I know in .NET there are ways to instrument your code base while it's running. So you can see in a production environment exactly what's been covered. So that could be useful. I don't know of anything that does that in Golang. There probably is something, but yeah. Cool. Should we move on?
I think Gustavo was trying to speak while on mute.
Sorry. Yep, go for it.
Still on mute.
Still on mute.
I was saying there definitely is a tool. I'll get the link for you guys. I'll post on chat if I find the name. I forgot at the moment.
Cool. That'd be great. Thank you. Cool. So the second half, as I see it, of structuring a project is around the application. This one's pretty obvious. There's a lot of good guidelines around how to do this. So this is probably a lot of what is pretty obvious to a lot of people already. I just thought I'd put this in just so it sort of covers the project side of things, the structure. Simplify complexity. If you have these, functions and interfaces that do a whole bunch of different things, it's good to separate the concerns out of them. Like having a utility that just does everything is probably not the best way to writing your code. Using meaningful folder names. As I understand, Golang has like the command and package paths for the main and the package approach. Splitting packages into small packages would make sense. Areas of concern. Things like dependency injection. I was reading up earlier today about hexagonal architectures, which is essentially just a way to loosely couple components within your application. Things like MVC, whatever works for context. I won't delve too much into this. This is just a structure type thing. Well, just on that, are there any other ways that people think that applications can be structured and Go? I know there's a few frameworks out there like what's it called? Web one. There's a few out there for like MVC and things like that. Cool. So this is the main part of what I'd like to talk about, I guess. And a lot of this comes out of Robert Martin's book. Things like keeping comments to a minimum. That helps you be able to visualize what the code's doing and not have a lot of lines in there that obfuscate what is happening. And when you feel the need to put codes in comments in code, comments should only explain why something's been done the way it is, and not how it is being done. Because if you're having to explain how something is done, that's exactly what the code's for, and maybe that's a prime candidate for that code to be refactored or rewritten. Another key tip is to keep your functions small. This is a very opinionated view, but keeping functions or methods under 15 lines of code would be my advice. Golang is rather more explicit than a lot of other languages I've found. I found that the functions get a lot bigger, a lot quicker, but there are, on the same token, there's a lot more candidates for reuse. So you might find patterns that are can be reused, like especially around like arrays and things like that. And the smaller functions make your test a lot easier, especially for unit tests. You get finer granularity in what you're doing, and you don't, like, say you've got a 100-line function and you want to write a unit test for that. That's going to be exponentially harder than something that's 10, 15 lines long, especially if you're retrospectively fitting that test back on. A couple of terms, the cyclomatic complexity. So cyclomatic complexity is the number of branches within your code. It's a measure of how, I guess, terse or difficult to understand your code is. And so the smaller your functions are, the less that cyclomatic complexity is, and the less cognitive load on the developer that is reading that code. And if you're testing a small function versus a large one, the name, and you have good names for your tests as well, you're going to glean a lot more information from those tests as well. And that, when you come back in 6 months, 12 months time, is going to be a lot more useful. Another thing from the book, Clean Code, is keeping number of parameters per function low. Ideally less than 4, in my opinion. Others might have other ideas around that, but it just keeps those functions very concise. Now if you're passing in like 20 functions into 20 parameters into a function, there might be a better way to do it, is all I'm saying. You could use a dictionary or a map or an array or something else that, or you could abstract parts out, or create an interface or anything, right? And obviously, anyone who's been around in development for long enough would know using meaningful names for your functions and your variables and all your objects within your code base. I know Golang isn't object oriented, but interfaces, things like that, is very useful. Your code should be expressive and declare its intent, and that comes back to method and function names in your interfaces, and be consistent. So if you've got two functions that do something similar, and they pass in the same parameters, or a similar parameter, or this same parameter, don't call it something different, because it's the same thing, right? It's just going to confuse people. Yeah. So, yeah. What are other people's opinions around this? Like, what have other people sort of?
I read the book, and I really liked it, but I actually wrote a review on my blog. But one thing I didn't like was the way he likes to go on with the very long identifiers, and he says not to use comments so much, but use long identifiers to explain what the code is doing. But then, that's the opposite what most Go code is written, because Go tends to use short identifiers,
that's a good point.
And I think having long names, you get it repeated all over the code, and it just makes things harder to read sometimes. So,
I know what you're saying, and in fact, I think Go linking has limits on the size of the functions as identified as well. The one I was using did.
I guess one of the things that I use, or I've seen a lot in the philosophy of the Go language, is about the concept of locality. So if you're declaring a function or a variable, and you're consuming it right after it or very close to it, then the length of the name is not as meaningful because you already understand the context around it. But if it's going to be used 20, 50, 70, 100, 200 lines later, then you kind of forgot what it is. So it's the length is kind of proportional to how far away you're consuming that variable or that parameter.
Yeah. So when you're talking about identifiers, you're talking about like variables, right? Like not the name of the function.
I'm talking about variables or parameter names.
Yeah. So I mean,
name.
Well, I mean, that comes back to keeping things very small, right? Like, I mean, if you've got 15 lines of code, like the method should be describing what that function is doing to the point that you don't need a large variable name. And like if you've got a large function name, maybe that interface needs to be broken down into a smaller set of interfaces. So it's all, I guess, relative, right? And just keeping things small so it's easy to understand. I
think sometimes there can be a bit of a conflict. Like if you break things like into very, very small functions and you don't want to have global variables, which you really shouldn't, then you have to pass around a lot more state between those functions. And while it's nice to be able to test them individually, you also have to then make those functions effectively part of your public interface when you don't necessarily want to. Like, you're just making the function public so you can unit test it. But really that function is only used once by another function within the same type. So sometimes it's maybe better to hide things within the function. Like, that's the conflict, right? Like while you're writing the code and while you're inside that class, maybe it's nice to have it separated out, but then you're shipping an interface, you're shipping a library to someone else. They suddenly see 20 functions, but they should really only care about one or two. As part of the interface. And you'll have more variables to pass around than if you kept everything within the function. So you've kind of got this conflict between the locality and the size, or like the goal to keep functions small versus having them, I guess, what's the right word? Like in isolation, they will look very cohesive, but the overall system might become less cohesive. Like it's less, each function will be very self-describing, very obvious, very sort of easy to use, except that it might have more parameters. But overall, you'll have more functions to test and exposed and to potentially confuse other users of your library.
Yeah. Are you saying in order to have that global state available to all the functions within that interface, you need to expose them all publicly?
Well, I mean, sometimes that's what people do just so that they can unit test them in isolation, right?
But you can still get coverage without testing all the functions. You shouldn't have to have them all public. You can still get the coverage by consuming functions that use those ones.
That's a good point.
Yes, but then you're sort of just testing like the parent function, like the one, I don't know if parent is the right word. Like you're testing the sort of main entry point.
Yeah.
And then everything underneath that isn't tested individually, which I think is fine, but there's a bit of a trade-off there. Like you kind of have to decide how granular you want to make it. At some point, it kind of swings back the wrong way in terms of complexity.
I can't remember if it's possible to test the private function in Golang. That's really bad. I should know that, but it's not. Okay. Well, yeah, it's definitely a trade-off then.
Actually,
surely with I was just going to say, surely with like reflection, like I don't know in .NET and other languages, like private functions can be tested with reflection. Once again, I'm not sure if there's something similar in Golang.
There is reflection, but if you're doing reflection to test something, then your test will be a bit convoluted, I guess.
Yeah, it's not really clean code anymore because one thing that certainly won't happen in those tests is like the function won't be showing you how to actually use the test function won't be showing you how the function under test is supposed to be used. If you're using reflection, that's certainly not the way that you normally want people to use the function.
Yeah, it was a bit silly of me to actually even suggest that.
I mean, it's some there may be cases for it, but
but not
yeah.
Case. Cool. All right.
Sorry, there was just one question.
Oh, was there a question? Yeah. What do we got?
Lisa was asking, is there anything to look out for that's specific to Go as someone who's just coming across from JavaScript? I guess for me, the big thing would be having type safety.
Type safety, yeah.
It's like having a linter, comparing the JavaScript linter to the compiler. But actually thinking about the format and style. Oh, sorry, yes. Will, you got any tips? Because you've used JavaScript before as well.
I've done a little bit of JavaScript. Yeah. Well, I mean, like JavaScript's obviously got types, TypeScript if you want type safety, but so JavaScript is a dynamic language, as I understand. Golang isn't. It's compiled into binaries, which is a slightly different approach. So JavaScript is jittered, like your standard, I guess VM type languages like C# and Java and that sort of thing. But yeah, I guess that comes back to your point there around type safety, right? Yeah. In terms of tests, it makes it easier to test things because you're not having to worry about a variable changing its type. Yeah, that's about all I've got on that. I'm fading a bit. It's really hard here.
I agree. Like in general, I think type safety or just having types has so many benefits. But obviously I'm biased. But I mean, one is it sort of helps with documentation, right? Like you're saying keep comments to a minimum. Just explain the why, not the how. Like the function itself should ideally be telling you what it's supposed to do just by its name, and then the parameter names along with the types for each parameter as well as the return type should tell you how to actually use the function. In JavaScript, you don't really have that. You really need to have those comments to say only pass an integer here and or whatever, like, or this date has to be in this format or whatever, and then in Go, like the compiler will make sure that that's the only way you do it anyway. So you can read the code to tell you how to use it, and then you've got that extra check done by the compiler if you happen to still do it the wrong way. So yeah, I think types are a huge benefit here. Yeah. No, I'm a fan of generics, so I can't wait for generics to be introduced because that's when you get the reuse without having to compromise.
In Golang,
like,
Yeah, absolutely. Yeah. So generics and exceptions are an interesting design choice for Golang not to have. So you're saying that generics are coming to Golang?
Well, they said that it's on their roadmap for next year. It's still a bit vague, but
actually we had a meetup earlier this year with someone who's was talking about the implementation and how it could potentially be implemented, and he was trying to get feedback. So it sounds like they're going.
Right.
Yeah.
That'd be good. Yeah.
Actually, Lisa's just made another point about in Go, there's a preference for immutability. It's a bit different in Go. It depends on how you structure your code, I guess. And what example?
Well, it's completely immutable because it's not a dynamic language. Yeah.
I guess it's also passed by value instead of by reference normally. So things are already copied around in Go. So by default, unless you pass around pointers, you will already get the immutability factor kind of in there.
Yeah. Yes. That also is immutability. The proper sort of immutability. Cool. So I'll move on. Tools and utilities. Yeah. So yeah, using many linters, there are different sort of validations that they can do. From every, like, I mean, Go has built-in linting. Like Go lint or something. If you type at the command line, it'll you know, fix up all your imports and stuff like that. But there's also yeah, linters for APIs and things like that that I've used in the past. And there's this Golang CI lint. I don't know if anyone's heard of it, but it's a way of sort of running all your linters at once. Using testing and mocking frameworks, that's, you know, just good practice with the unit tests and integration tests sometimes. Code coverage tools, I mentioned that earlier. And Gustavo has a good link to something for in code coverage in prod, I believe. I'll share later. And pre-push commit hooks. In the past on a Golang project, I used Husky. And Husky is great because you know, it can run your test for you before you do a git push. And that can be quite useful for saving from pushing things into a source, into your code base that is faulty or would cause your pipeline to break. Yeah, so as I mentioned before, I found Go a little bit terse. Like, you have to describe exactly what you're doing, but there are helper packages out there for things like that. So the things like GoLink, which is language integrated queries within Go, and that makes your code a lot more succinct, and that can also help with readability. And it's like GoLink's a way of like enumeration collections essentially, and you can make your code look like almost like SQL statements within your Go. And yeah, use your tools well, like RDE, refactoring. Golang's got extract methods and interfaces and all that sort of thing. There's also editor config, which is a good way if you're working in teams for having standardized formatting across your code base. And that can be, integrated with like Husky and your tests and things like that to prevent anything being checked in that doesn't meet the format that's been agreed upon for that code base. Not so much around clean code, but just a general suggestion is to use like a bootstrapping approach for your projects. Something like a makefile or a shell script. There are other tools like Detect, which is by ThoughtWorks, and Docker Compose, just for putting things into putting all your common tasks into a reusable approach. So anyone can just quickly clone the code base and run things locally. Just on that, are there other tools and utilities that have helped people? Yes. Oh, cool.
Do you, when you move to a client site, do you bring in a bunch of tools? Because that would be a good technique. I know I've done one in the past.
Yeah, I have. Yeah, so it depends on how mature their technology stack is already. Yeah, that comes back to influencing the customer as well, and how readily they will take on the tools that we suggest to them. Yeah, and it also depends on what sort of stage of the project you begin at. Does that sort of answer your question? If it's like greenfields, like obviously, well, with clients, like they've obviously got like existing stacks that they work with, so their architects probably prefer that you work with those. But yeah, it varies from project to project. Yeah, so I mentioned before breaking down functions, extracting out those commonalities in your code base, putting them in their own package. Sounds like that would be a lot more effective once generics are part of the language. Yeah, finding that reuse and drying up your code base. So dry is an acronym for don't repeat yourself. And if you've got the same code over and over in your code base, it's probably an indication that could be put into a common package or interface. Another thing I'd like to sort of stress is that it's really important to be proactive around keeping your code base clean. You know, when you're working on a story or something, and you see that there's bad code there, it's the best practice is to, in my opinion, to clean up around that area as well. You know, if you see some quick wins that you can clean up in that area, it's quite useful to do that. I'll just skip over the optimized one. There's a broken window theory, and so the broken window theory is it's around social norms, and the broken window theory was some research I think they did in America, and in neighborhoods they did some tests on like buildings where they've been like left derelict, and but all the and they've been at that for like a year or something, and all the windows were fine. The windows were there and they were fine, but they did a test where they broke one of the windows, and it was within like 24 hours or something that a whole bunch of other windows in that building started to get smashed by local residents, and the reason is that if there's like so if people say that there's one window smashed, they almost think that it's acceptable to smash other windows. They think that it's just a derelict building and it doesn't really matter. And so the analogy to code is that, you know, if people sort of, you know, we're social animals, and we work on social norms as human beings. And if we see a code base and we see just like, it's all messy and we don't really care, then people are just going to follow suit with that, you know, and they're going to just, you know, accept that's the norm for that code base, and they're just going to, you know, put crap in there as well. So being proactive sort of helps with that a bit, I guess, and keeping it clean, and sort of preventing that code rot. Darren's got a question: damp versus dry. I haven't heard of damp. Do you want to elaborate on that, Darren?
Coming around sort of dry, sort of like so you don't repeat yourself, but so like with the Go, it's also like sort of descriptive and meaningful phrases, where sort of promoting the readability of the code, which is not sort of the opposite of dry, but it's sort of you can have the two together, sort of well, not necessarily not repeating yourself, but sort of not necessarily being as dry, but you know, sort of it's that sort of interplay between the two to sort of maintain that readability versus being, you know, absolutely dry.
So leaving in some detail for clarity, rather than refactoring everything out and having to step through 10 separate methods to figure out what's going on.
Yeah, because you can take dry to that extreme and then make your code so clean that it's very hard to maintain, because you have to step through all these sort of, you know, functions and stuff, but actually leaving a little bit of stuff in there to make it a bit more sort of descriptive and a bit more sort of readable.
Yeah, that's a good point. I haven't heard of that before, but I guess the one bullet point I skipped over: don't optimize too early. That sort of covers that, right? Like, I mean,
yeah, it's a lot, and it's a very sort of Go thing as well.
Right. I haven't heard of that.
I think that's true. Like, that's another principle, but it relates to both of these. Like, you don't want to make something reusable until you need to.
Yeah.
Like, you know, don't parameterize your function just because one day you might want to tweak something when there's absolutely no reason to have that configurability at this point. Like, sometimes it's actually better to hard code something, because likely you'll either throw away that piece of code before it's going to get reused, or it'll just stay that way forever. Like, I mean, I don't mean hard code like a secret or something or URL, but even with numbers, like sometimes it's okay to, you know, if it's like a 20% off promotion, the first time you're doing that, hard code the 20%, and the second time you want to like make it 15%. Maybe that's the time when you make it configurable.
And that's the way good TDD is done. You write a test to do the minimum required, and then you build on that with another, and you do red light, green light, refactor. So you write your test, Do the implementation, that's good. Write your test fails, that's your red light. Do the implementation, that's your green light, and then you refactor that. And it's only the smallest amount of the implementation, and then you write another test that builds on that, and then build and bigger. But coming back to readability, yeah, absolutely. Yeah, it's I haven't heard of DAMP before, but it's an interesting concept.
Does it stand for something? Is it actually an acronym?
Yeah.
Don't repeat yourself.
Yeah, descriptive and meaningful phrases.
And that comes back to readability as well, right? Like,
it's funny how DAMP was not that.
Oh.
I mean, it's not descriptive and meaningful until you know.
But yeah, that's a great call out, Darren. Yeah, that's definitely readability. And yeah, the Boy Scout rule. You know, you leave the campsite cleaner than when you got there, and it's just a good way to code, in my opinion. Cool. So now you're all converts of clean code. You know, how do you influence? Like, you know, if you're on a team and you got some sort of you got people sort of pushing against it, they just want to get things out the door type thing. This is my advice. Just my advice. Could be right, could be wrong, but it's you know, use the existing channels that you've got. All right, like, you know, if you've got a tech lead and they're open to hearing about it, you know, try that first. If you do retros, bring it up at a retro. You might get a few votes and you can chat about it with the team. And you know, if the team is generally pretty good, but there's just one or two, maybe just have a word to them. And things like pair programming are good for that. Like, maybe you just pair with them for a bit and, you know, show them the way it could be done instead of what they're doing. You know, show them the light. And yeah, obviously, you know, there can be issues trying to influence people around it. There can be resistance. You know, like the previous engagement I was working on, the tech lead actually wanted to do a sprint in the final sprint just of tech debt. Or actually, it was a penultimate one, and it was really bad because you know, everything is sort of settled into place by that point. And we just did a complete refactor of the code, like these massive methods and functions and stuff, and they're all split up and they were put into different files and different, you know, different hierarchies in all the folders and stuff. And then we had some more sort of functional work we needed to do. And like, I personally, I couldn't understand what the hell we'd done, because everything just completely moved around, right? It wasn't sort of, we didn't evolve the code base. We just completely just blown it out of the water. And it was really bad. Yeah, and so the resistance, coming back to resistance, that's usually by non-technical stakeholders. You know, like if you mention at a stand-up you're doing like you know, I'm just doing some refactoring as part of this. Some great advice from Martin Fowler is, don't tell them you're doing the refactoring. Don't tell them you're doing clean code. That's just part of the story, right? That's part of the ticket. Just do it anyway. And then the team norm will be, yeah, it takes a little bit longer to begin with, but you know, once you start getting your velocity as a team, you'll be fine because you've got a clean code base and you've got all your tests. You're doing great. A couple of examples. So that tech lead that wanted to do the refactoring, I was actually doing refactoring before that and cleaning up the code base a lot earlier than that final penultimate sprint. But he was getting a bit of rage about that. And I kept letting him know in Slack, I'm doing some refactoring. Doing some refactoring. He was like, okay. And then he was like, please stop doing refactoring. I'm like, I'm only doing the refactoring because it's such crap code. And like, look, I got to talk to you about this a bit later because this is really bad. And so we had a half-an-hour conversation, and he tended to agree with me after that. But that's the wrong way to do it. The best way to do it is when we had a QA on the team, and the QA wanted to write some code, and you know, the QA is pretty humble, and you know, he's down to earth, and he was open. Like I said to him, look, this isn't great code. And it was actually JavaScript, it wasn't Golang. This isn't great code, but maybe we sit down together and, you know, spend half a day or a day and we can make this better. And he's like, yeah, that's cool. Yeah, I'd like to do that. And, you know, we both learned from that, you know, like I learned what he was working on, and he learned how to write clean code, which is great. Do others have experiences around that as well? Anything they'd want to share?
I guess where I'm working now, it's a small startup, but they've always done TDD and really pushed for clean code. And we just hired a new person, and the new person, I don't know where they were working, where it's always like a race. It's trying to finish the cards as quickly as possible.
Yeah.
And I would spend ages crawling through his PRs, you know, pointing out things like, yeah, like the code quality or the little points. Yeah. So anyway, we introduced a linter, made it a bit stricter, made it part of the pre-commit step, but and in the end, we ended up just taking a couple iterations where I ended up pairing with him just to kind of get the process in. So, yeah.
That's the thing. Yeah, it's just about having patience with people. Right? I mean, we're not all on the same level with our coding abilities. And you know, sometimes people need guidance and mentoring. Sometimes we need guidance and mentoring. Right? It just depends on the circumstance. So yeah, that was great. Oh, that's it. Cool.
Some questions. Oh, this is the right slide. Yes, questions, comments, complaints. Yeah. The thing about like just refactoring along the way and not telling anyone. Like, I mean, I if it was my personal project, yes, I would do that, and to some extent, I do it on larger projects too. But there's always sort of this risk that if you touch code that you're not really supposed to touch as part of your story, and you're only touching it because it happens to be nearby the thing that you're working on, and you're like, oh yeah, I might as well fix this thing too. But then, you know, there's a risk that you might break things, that you confuse other people, and they'll be like, why did you touch this code? Like there was no need for you to even be there. Point.
Yeah, look, like I hear that, and the first thing I'd say is that the test coverage should be at a level where you could do that to begin with. If it's simple things like just removing comments, I just do that all the time anyway. I don't care what people say. I just get rid of those comments because they're already they're in your source control anyway, right? Like you're not losing it.
Yeah.
And when it comes to renaming variables from like, you know, var I to something more meaningful, then I'm just going to do that too. But yeah, like things that are more functional, you know, they're the sorts of things I guess I bring up as a team and say, look, there are better ways to do this. And you maybe put a separate ticket in for something like that. It just depends, right?
Yeah, and I think in like Golang, it's safer to do refactoring and rename things using the tooling because it's statically typed.
Yeah.
And assuming if you've got good tests, you can do even more of that. But imagine if you're in JavaScript. And especially like
you're probably in a world of pain there.
maybe I've just like had bad experiences and no one else had those, but things just tend to get worse and worse over time because no one wants to touch anything.
Yeah.
But you get to that point so quickly that there's really no other way.
Well, yeah, I mean that's I guess that's why I come back to 90 to 100% on the test coverage, right? Like if you have that confidence from those tests and you want to refactor things, those tests are going to tell you pretty quickly if you've broken something, right?
But it's so, I mean, there's so many tests. In theory, like even if you have 100% test coverage in JavaScript, because it's all dynamic and you can do like 100 things 100 different ways.
Yeah.
It still doesn't cater for all of the things that you could break. In a language like Go, it probably does. So it's
True.
Yeah.
I
think Go is good.
Yeah. Well, just on JavaScript, there are other sort of ways to work around that. Like Martin Fowler has a book called Refactoring 2 that was actually written against JavaScript. And there's also a book by Martin Feathers called Working Effectively with Legacy Code. And it talks about things like putting themes into your code and write tests around those. So it's essentially sort of just cutting out the bits of code that you want to test and change.
And I think that's good advice if you are in that situation, but it also adds another thing.
Yeah.
That in some ways makes your code maybe not less clean, but more complex. Like it'll never look as neat as greenfield code.
No, one thing that I've definitely I find helpful that is not often talked about is Git etiquette. Let's put it this way. Like don't make a commit with 17 different changes that are unrelated to each other. So for example, if you're changing or refactoring something that you saw that is not really directly related to the thing you want to do, maybe put that in a separate commit. And if someone's really pissed off at you that that's a change, okay, you're fine. I'll just remove that commit from my change request, and you can be fine with that, or you can say, I'll just put this commit on a separate pull request, and we can talk about it if it's not directly related. Plus, following that story in changes when you do some code review, when you come back to something later, it's easier to also understand the evolution of things, which I find really helps in the conversation.
That's a great call out, and probably something I should have put in the slides. I've worked on large code bases that started the application started failing intermittently, and no one could figure out why. And so we had to I essentially ran deploys for every single code commit to find out where it started breaking. And the more fine-grained your commits are, the easier that process is, right? Because you can more easily hone in into what exactly is causing the problems. And the second thing I'll say about that is, if you're working on a lot of organizations these days use like GitHub and that sort of thing. If you have a team responsible for a code base or a repository, and you're accepting pull requests from other teams, that team doesn't want to sift through like your 17 changes in one pull request. They want something that's easier to merge into their code. And it increases your chances of getting your changes merged as well.
Is that maybe a bit of an argument for not doing the feature development and the refactoring in an interleaved way? Yes, ideally you'd say.
You do it at the same time, but you're putting in a separate commit. Yeah.
Yes,
I wouldn't advocate. Yeah, I wouldn't. Well.
But let's say even if you are super disciplined with that, but then you've got 20 commits, and then half of them are refactors, half of them are feature related, and then you submit a PR, and then someone still has to look at that.
Yeah.
You're not going to actually submit.
Relevant commit messages go a long way as well, right?
Absolutely.
If you just say fix something, then what the hell did you fix? I don't know what this means. But if you actually describe and maybe put a multi-line explanation down the bottom for a reason that your refactor happened or improvements that you want to make, that makes it a lot easier to digest and potentially accept.
Yeah, true. Well. It also discourages you from doing it.
Yeah. The only other thing I'll say about commit messages, it's good to put them in what's called the imperative voice. So as an instruction. That way, when you're looking back at it later on, it's a lot easier to read as well. And that reduces the cognitive load. So like instead of fixing tests, it'll be fixed test. As a very simple example, but yeah.
Please
yes,
I fix test.
Yeah, no, of course, but like,
not like that.
I'm still thinking and I like doing the refactoring while I do other things, but if you really want to separate them into separate commits, you'll have like a commit that says rename variable I to index, and you might have that message like 5 times in 5 different functions. So because you might not be doing those 5 different functions in one go, but in between other things.
Yeah.
It just gets a bit painful.
Mm.
And then maybe another tool that is, or I don't know if it's so prevalent in other languages, but I really love that Go and Go docs are a thing, and your comments become documentation for your interfaces and the tools you develop. I find that super helpful because sometimes, adding a comment, you usually think, oh, no, nobody's going to read this anyway, or maybe like, why would I be so descriptive? Some guy's going to just dismiss it anyway and change the logic, and everything's going to go to hell. With Go Docs, you can publish it as an actual document in a page that people can go to that have links to other things, and it really increases the value of having good comments and not just random stuff.
Absolutely, yeah. I've seen Go Docs; it's really good. I like that approach that the Go language has taken as well. It really supports every repository is its own product in a way, and selling that product.
With the Go docs, if IDEs can preview that as well. So like certainly some IDEs do that with Java docs, where you call a method and it actually then shows you in the a tooltip kind of UI element
they can,
what the method is and what each parameter is for.
They can.
Yeah, that's good. Like that's sort of real time. I guess even going back to the principle of having fast feedback, like you sort of like putting that in ahead of time, like you rather than letting people fail and then telling them what they did wrong, you're sort of giving them, you're putting things in there ahead of time, but you're not overloading them because it'll only appear for them when they actually need it.
Yeah. You're giving them the most information at the most opportune time to make the best decision about how to put against that interface.
Yeah.
You use Go a lot at ThoughtWorks?
I've used it on 2 projects in the last year, so I feel like it's getting more popular, with clients at least. The most recent one was like using gRPC and stuff, and that's pretty cool. I really enjoyed that. That was with a big domain. The other one was just microservices and stuff.
I was actually going to ask about gRPC in this context, like because there's a bit of an argument. I think gRPC is great because it's kind of, I mean, I shouldn't say it's great because it's like soap, but you know, but you know what I mean? Like you've got a very, very strict interface definition and you're coding against that, and you can have tooling around it. And it's not like, oh, yeah, just post some random JSON to this HTTP endpoint and, then you have the Swagger definition, and kind of looks like this, but it doesn't tell you all the details of how each type should be formatted. So from that point of view, I think it's actually good from a clean code point of view. It's kind of self-documenting, but at the same time, it's not, because you need special tooling for it, whereas JSON is just human readable. And
I found it really good. Like you've got your Protalk file, right? And that's your definition for your interface. And then I think there's some tool you use to generate your Golang behind the scenes for that. And that just does all the wiring up for you. And if you want to communicate with that API, there's a tool called Bloom RPC which makes it pretty easy. And you can just create your JSON and just communicate with the endpoint.
Yeah, I guess a lot of people are saying no, but I want to be able to inspect my packets and see it in plain text. And
there is that as well.
People use Postman and
I mean, it's a binary format, right? And it's binary to make it quick across the wire.
Oh, yes.
And that's the big advantage of it, but it's also a disadvantage, I guess. Trade-offs, right?
Do you think maybe, do you think the tooling is quite there yet, so that you could actually convince people to switch over, or do you think it will ever get there? I would hope that it will.
There. Yeah. There's actually there's an SE Radio podcast around it as well. But and they had the product manager of gRPC on there. He seemed pretty bullish about the future of it. I don't know. It's one of those things. It's useful, and it has its place, but it's not for everyone, right? And it's just using HTTPS over the wire. And using HTTP 2 as well. Yeah, that's right.
Yeah.
So
which is fine these days, but again, it's not as easy for people to just sniff your packets and just watch what's going on. But I think it should be that hard to actually build tooling that does that and then renders it as if it was JSON even. So why people seem to make this big deal about it has to be plain text, so it's compatible for eternity and human friendly and all that stuff.
Yeah.
But it's just text is a binary format too. It's just that there's a standard way of rendering each byte into a letter. And that's with ASCII. When you go to UTF-16, it's not even the case anymore. Like
Unicode and stuff.
Yeah.
Right. I gotta head off. Thanks for the chat, Will, and thanks for the conversation.
Thanks, everyone.